in Chapter 4, Lesson 5 and Lesson 6, multiplying and dividing integers. Now we're going to focus on where we've been, adding and subtracting integers, and now we're going to head into multiplication, we're going to head into division, and of course we're going to need all of this to solve two-step and later on multi-step equations. So our objective for today, I will multiply and divide integers. At this time, go ahead, no matter what the date is, no matter what the assignment is, go ahead and copy this down. Come on back when you're ready. All right, folks. Rules for multiplying integers and dividing integers are very different than adding and subtracting. I want you guys to understand what the rules are and where they come from. But first, I really need you to take a step back. What does multiplication mean? For instance, what is 3 times 4? Remember that multiplication is really nothing more than repeated addition. 3 times 4 quite literally means 3 groups of 4, 4 plus 4 plus 4. Now, naturally, that's going to equal 12, but what would happen then if you had changed the problem to 3 times negative 4? Remember though, it's still repeated addition, 3 sets of negative 4. So if you were to add negative 4, going down repeatedly, another negative 4, go down repeatedly, another negative 4, you guessed it, you're getting a negative 12. So please remember what multiplication means. If you're repeatedly adding negative numbers, if you're repeatedly going down, then you're going to have a negative answer. And if you have a negative times a positive, that also is going to be a negative answer. All right, take for instance, negative 15 times 3. Now, quite honestly, I'm often going to treat this using the multiplication property, the commutative property of multiplication. If you were to go down 15 3 times, then clearly we're below water, and so we're at negative 45. 8 times negative 6, going down negative 6 repeatedly, and if you're repeatedly going down, you're going to be below water. You're going to be in debt. What about negative 9 times 11? Well, you could simply reverse that and imagine yourself going down 9 11 times to get a final answer of negative 99. And then, of course, 7 sets of negative 4. If you continue going down negative 4 and another negative 4 and another negative 4, naturally you would be 28 feet below water or $28 in debt. Those are but a few examples of multiplying positive numbers times negative numbers. No matter which comes first, the positive or the negative, just continue to think, what is multiplication? Repeatedly adding numbers. And if you're repeatedly going down, it's going to be in the negatives. Now, what happens though if both numbers are negative? For instance, a negative 3 times a negative 4, whatever the case might be. We already know that a negative times a positive is a negative. Let's continue the table. Think about negative 5 times 2, negative 10. Negative 5 times 1, a single time going down 5. And of course, anything times 0 is 0. But then what would negative 5 times negative 1 be? Pause the video if you need, look for the pattern and come up with a prediction. So here's the deal. You can kind of see a little disappearing ink here. That increases 5. That increases 5. If you continue along with that pattern, you're naturally going to get to a positive 5. What about negative 5 times negative 2? That would be a positive 10. The question, ladies and gents, is why? Why does that happen? A negative number multiplied by a negative number is always going to be positive, but why? Really? It's all about opposites. Think about that problem, negative 5 multiplied by negative 2. Imagine that negative's not there, so you're repeatedly adding negative 2's. The problem is that symbol is there. So not only are we taking 5 negative 2's, but we're taking the opposite of all of those. That, folks, is how we get back to positive 10. So that symbol that so many of you, all you think of is the word negative, really, ultimately what that symbol means is opposites. Negative numbers, what are they? They're the opposites of their positive counterparts. So for instance, if you were to picture, act like that negative's not there. 2 negative 4s. Okay, so you go down. Let me draw this out with pluses and minuses. 1, 2, 3, 4, 5, 6, 7, 8. And so you might be tempted to write an answer of -8. However, the negative symbol, the opposite symbol is there. And the opposite of all those negative 4s become positive 4s. That becomes a positive 4, and therefore, we're going to add 8. Now think about it in terms of a number line. Pretend that this symbol is not there. So 7 negative 4s, down 4, down 4, down 4 repeatedly. And you might be tempted to say, all right, -28. But the symbol is there, and the opposite of going down repeatedly would be to go up repeatedly. And so therefore, this answer is going to be positive 28. -12 times -3. Remember what multiplication means. If you were to say 12 -3s, -3, -3 over and over, you might be tempted to say -36, but we need the opposite of all those -3s. So we're actually repeatedly adding positive 3s. And in like manner, -5 times -8, if you were repeatedly to go down 8, it'd be -40, but the opposite of going down repeatedly is up. So take a pause for a second. Some of you are really going to like thinking about the pluses and minuses. 2 -4s, the opposite of those, it all switches. Others of you are going to think about number lines. Instead of repeatedly going down 4, you're going to repeatedly go up. Others of you still might prefer thinking about repeated addition. Instead of repeatedly adding -3s, you're going to add positive 3s. One way or the other, you have to see that the opposite of negatives, the opposite of repeatedly going down, is to repeatedly increase, to repeatedly go up. Now let's go ahead and put this together with a number of problems. So here we are with 4 different expressions. Nothing between the 7 and the parentheses, so we know these mean multiply. 7 -5s is -35. Oh, no, Mr. Cowan, the opposite of all those negatives are positive. Now we go ahead and multiply because we knew that multiplication was equally strong going left to right. 35 times, you're going down 3, means you are ultimately going to be down, oh, careful, Mr. Cowan, -105. Let's go to the example right next to it. Again, going left to right, 4 2s is 8. Oh, no, the opposite of those positives would be negatives. Now we go ahead and multiply. Repeatedly adding -5s would get us below water. However, the opposite of all those negatives are positive. Final answer here, positive 40. Once again, you're welcome to write the times symbols if you wish. 6 times you go down means we're going to be at -6. 6 eighths is 48, but the opposite of all those positives. You could have also switched it using the commutative property and seen that you're going down 6, down 6, down 6. That's going to be a -48. Don't forget what an exponent means. An exponent means a number multiplied repeatedly by itself. And because our exponent is 3, we're going to multiply it repeatedly 3 times. Now, this says -2 multiplied by itself. Going left to right, 2 2s is 4, and the opposite of a negative is a positive. Meanwhile, 4 times, we decrease -2 each time for a final answer of -8. Look at how those problems are similar. Look at how those problems are different. Bring some questions to me if you have any. Let's go ahead with one final piece of multiplication, and that's going to be evaluating expressions. Now this says -6 sets of A, where A in this case is going to be -3. 6 -3s is -18, but the opposite of those negatives turns to positive. A times B times C, where A is -3 and B is 4 and C is -5. And you guys know, Mr. Callan, I don't like putting two symbols right next to each other, so I'll often put a parentheses there. Now, multiplication is equally strong. We're going to go left to right. So -3 times 4, the opposite of 3 fours would be -12. And the opposite of a negative would give us a +60. Last example, -2 times B times C. If you want, pause the video, do it on your own. Come on back when you're ready. I'm going to put parentheses here, but really this just means multiplication. -2 times 4, the opposite of 2 fours is going to be -8. And the opposite of going down repeatedly is going to be going up repeatedly for +40. Now, let's talk about division, shall we? I would venture to guess that you really truly understand what division means. If you were to split 12 up into 3 groups, naturally there's going to be 4, or could I say +4 in each group. On the other hand, what happens if you have $12 of debt? What happens if you owe $12 and you split it among you and 2 friends? Well, naturally, everyone owes money. All right, so what happens if both the 12 and the 3 are negative? Again, if you were to pretend that wasn't there, -12 split up into 3 groups, sure. But then it says, what do we have to do? You guessed it, take the opposite. And if we were to take the opposite of all those negatives, it'd be positive. Meanwhile, and this gets interesting, what happens if you split 12 into 3 groups and you're tempted to say +4, but wait a second, Mr. Count, we need the opposite of all those. Well, in each case, all those positives are going to change to make a final answer of -4. Once again, the focus is on opposites. I could have made that green, I suppose. The focus is on opposites. It doesn't matter who's bigger. It doesn't matter who's smaller. If you were to split up a debt of $25 into 1, 2, 3, 4, 5 parts, then everybody owes $5. On the other hand, if you take the opposite of all those negatives, be positive. If you were to split 48 into 6 parts, you'd get 8, but the opposite of those positives turn negative. And if you were to split -48 into 6 parts, that seems like a negative, but the opposite of those negatives are positive. Algebra, save some time here. I'm going to cancel out this one. You can do it on your own if you wish. 18 divided by B, which is -3, and C, which is -2. Now, there's no symbol in between, which means this is going to be multiplication. But recall, please, that multiplication is equally strong, so we're going to go left to right. Now, if we were to divide 18 by 3, we'd get 6, but the opposite of those positives turns negative. 6 -2s would be -12, but again, the opposite of those negatives turn positive. Final answer there is +12. Now, for the last example, we have A plus B, A being 18, B being -3. I'm going to put that there. I won't this time. I know our textbook doesn't do that. Divided by -5. Now, this is interesting, folks. It's hard to divide unless you know what you're dividing by. It's almost like you should draw your own little grouping symbols. So 18 and -3, we're going to go up, we're going to go down, we're still in the positives. Now, if we were to divide 15 into 5 parts, we'd get 3, but the opposite becomes negative. Interestingly, any integer multiplied by 0 is 0. But any number divided by 0, you can't do it. Think about 6 divided by 2. You split them up into 2 groups, there's 3 in each group. 6 divided by 1, there's 6 in that group. But can you have $6 and split it up into groups of 0 and still have $6? That's impossible. So we often use the word undefined. To recap, I know some teachers like to give shortcuts, but you guys know me. I want you to understand that it's really all about opposites. When it comes to multiply, when it comes to divide, the opposite of all those negative, turn positive. If you repeatedly go down, it's going to be negative. The other way to think about it, the opposite of positives are negative. The opposite of going up repeatedly would be go down repeatedly. In like manner with division, opposite of negatives are positives, opposite of positives are negatives. You need to write that word opposite 10 times before you start this assignment. That's what I got for you, ladies and gents. Whatever the assignment number is, whatever the date is, take care, do well, and let's grow.